Hello friends, welcome back to the Amit Dhakad AI. Today we are going to learn about multi-threading in Python. So now before your eyes close off, I promise you once you understand what I am trying to explain you, you will never look at your computer the same way again. So first my question is like when you open YouTube a video, right? So a video is downloading and you can scroll through a comment section. So how this will work? So how can a computer do two things at once? Like this is exactly what we are going to understand today. But at the end of this class, you will know the computer juggles multiple threads, multiple tasks, why it sometimes goes wrong, and how professional developer fix it. So what is process? Think of your computer like a big office building. A process is like one complete separate company that rents the entire floor of the buildings. It has its own office, it has own logged, it's have on cabinets, on its own employee, its own printer, its own everything. So when you open Google Chrome, that is a process. When you open VS Code, that is another process. They are completely isolated from each other. So Chrome cannot touch VS Code memory. They have their own private space. So in technical terms, a process is independent execution environment with its own memory address space. When Python runs your script, it creates one process for it, and processes are safe and isolated, but they are heavy, starting one task time and memory. Now, what is thread? If a process is entire company on one floor, so the thread is individual employee working inside the company. One company can have many employees, like many threads. So, and here is the official part, like all employees share the same office space. So they share the same cabinets, they share the same printers, they share everything. So threads are lightweight, they are quick to create, and they are share memory. But because they share everything, if one employee mess up a shared file, it affects everyone. So all the threads inside the process share the same memory, including all global variables. So this is the superpower and curse of the thread. So what is concurrency versus parallelism? So now here is what so now here is where most beginners get confused. There are two different ways computer can handle multiple tasks. They look similar but they are very different. Let me explain with the real example. Imagine I am a chef in kitchen and I have to cook rice, make curry and bake bread. So in sequential, I finish cooking rice completely, then I can start curry and then I can start bread. And next I have like concurrency. Once I start rice, right? So when I put the rice on the stove, while I Concurrency: once a switch between tasks. So I put the rice on the stove while I boil chop vegetables for curry. While curry simmers, I need the dug. I am switching between tasks quickly. It feels like I am doing three things at once, but I only have one pair of hands, so I am only switching rapidly between tasks. In parallelism, like there is a three chefs working simultaneously in three different tasks. Like one is making rice, one is making breads, and one is making curry. So Python's thread module, what it is like it is concurrency or parallelism. So Python module is concurrency based. So Python threads don't usually run in task like run tasks parallelly. They rapidly switch between each other tasks, like downloading files, reading from database, making API calls. Okay. So before that we go deep, first we will understand the uh, processor. So what is the core? A CPU core is a physical process unit inside your computer chip. Okay. So dual core is the that is having two core, and quad core is four core, and octa core is the eight cores inside the CPU. Okay. So this is the simulator. This I will explain you later. So before that, I will show you the example. Okay. So I have this program. I will run this first. Okay. So you can see here thread worker 123, thread 312, all request completed in 0.52 seconds. Okay. So what is the thread? Like how we can create thread? So we don't have to create any new library or anything like. So thread is we need to just import thread. Okay. So there is a one function fetch post. Fetch post. So that will take one post ID and it will fetch the post. Okay. So here just printing, this is one URL from where we are fetching the post. Okay. So this is we are doing request URL open. Okay. So as a response, here we are json.load response.read and decode, and here we are printing the title and we are printing the worker name. Okay. And if it will throw error, so we are throwing the error. So we are using try and except for that. So this is our function. Okay. And the main what we are doing, this is we are just calculating the time, how much time it's taking. Okay. So this is our main function. You can see here I have T1, T2, T3. So what I am doing, I am creating threading dot thread target. So what is the target? Target is the any function that you want to call. Okay, so we are passing the fetch post. So here you can see we are passing the argument here, and we are passing the ID one. Argument is that what argument you need to pass to that function that you are calling here, like target for target, what argument you need to pass. So that is we are passing, and we are using comma in the end because this is like a tuple. Okay, and we are giving the name like worker one. Okay, so this is just creating the thread, it's not starting. Okay, so this is just creating the thread. Similarly, we created three thread for 1 2 3 post. Okay, so this is how we can create thread. After that, you can see we are seeing T1 dot start, T2 dot start, and T3 dot start. So it will start the threads immediately. Like first T1 dot start, it will start T1. We are calling T2 dot start, it will T2, and it will start T3. Right. So when we call dot start, it will execute the threads, and our code will start the executing. Next we have T1 dot join, T2 dot join, and T3 dot join. So this is synchronization steps, like synchronize main thread. Okay. So tell the main thread stop here and wait until the thread finish the work. Okay. So we are doing T1 dot join, T2 dot join, and T3 dot join. After that, it's just calculating time and it's printing. So how it works? When we are starting T1, when creating thread T1, T2, T3, so these just creating, these are not starting. Okay. So once we start T1 dot starts, it go to the fetch post function and it will start the fetching the post. Okay. Similarly, we start T2, it will start, you can see here fetch post 1, fetch post 2, fetch post 3. Okay. So it will go to the fetch function 3 times for each thread. Okay. So what you can see here, thread dot worker 3. Okay. So three worker started, three worker using calling the fetch post function, and you can see the first one is printing thread dot worker and title and thread worker 1 and thread worker 2. So this is how this is doing, because first we called T1, but you can see the output it is showing worker 3, right? So this is depend on the time taken by the network call, right? So when we started worker 1, 2, 3, right, at the same time using the 3 dot start. So it will depend on the which one is complete first. This is completely depend on the network that we are calling here, a network call, like we are doing fetch response, this one fetch request dot URL open. Okay, so the third worker is finished first because the network call taken by the third worker is less. So this is how this code is working. Okay, so this is how the threading we can create in the Python. Like we need to use import threading, we need to create thread object, and we need to pass the target, and we need to pass the we need to start the process, and we need to join for the module. So here we have next race condition. So we need to talk about the dark side of the threading. This is we are beginner grade 1. So this is where real production software has gone down. So this is called race condition. Because threads share the same memory, so they can read and write the same variable at the same time. And what happened without production data get destroyed. Okay. So we'll understand this by in this example. So you can see our answer is 100 for this one. Okay, so we need to import threading. So we have shared counter here 0. So we have one function. Okay, inside that we are using global shared counter. We are having range 100 for underscore in range 100, right? And we are having temporary variable that is storing the shared counter, and we are using time dot sleep, and we are doing share counter equals to temp plus 1, right? So post GL context switch. This is something that Python provides GL that is handle the threading inside the Python. Okay. So we have main function here. We created two threads here. Threading. You can see we are passing target here. Right. So we are not given any name for that thread, and we are not passing any argument because this function is not taking any argument. So we just passed threading dot thread target equals to increment. So this is creating thread 1, thread 2, T1, T2. It will start same way T1 start, T1 2 start, and we are doing T1 dot join and T2 dot join. Print final shared counter. Okay. So what should be the expected result? Because we have shared counter 1, right? So this function is called two times increment here for thread 1 and thread 2. And what we are doing 4 underscore in range to 100. So 100 times it will work, and 100 times for the second thread, right? This is T1 and this is T2. Okay. So this is if we are running this function two times and we are using same global variable. So the output should be the 200, right? But it is printing the 100. So this is the issue with the race condition. Okay. When race condition happens, this issue will face. So what exactly happening here? Okay. So you think we are having temp plus equals to plus share counter equals to temp plus 1, right? So this is here you can see. So what it will do, it will first read the value, right? Counter plus equals that is same temp plus 1. Okay, so read counter value, it will read the value for temp. After that it will add value to the 1. Okay, and after that it will write back to the shared counter. So these are the three operations, so right? Shared counter, three operations here. Like first it will read count value, it will add 1, and it will write back to the memory. So what is happening here when we are running these two? So first, like first counter will go here, right? So it will start T1. So it will go here, it will read share counter is 0. And it will go inside, so it will assign temp equals to 0, right? And it will go to sleep. Next, the T2 is started, so T2 will also come here, and for temp, for T2 also, temp equals to 0, right? Because the T1 is not incremented that time. So temp 2 is 0. So it will go here, it will also go to sleep, then T1 will wake up. So it will go to there, so it will do 0 plus 1. So set counter is 1, right? And next, this is completed. Next, it will go to the again here, and it will read the value 1, right? So it will go to sleep again. Till here for T2, what is the temp value here is still 0, right? So it will go to the sleep like temp plus 1, and it will also be 1. Okay. So when the T1 is incrementing any value for cell counter, that value is not able to access by the T2 because of the race condition. Because the T2 is using the old value only. Okay. So that's why the output is the 100 here. So this output also depend on the your system, right? So when you run it multiple time, you will maybe get different. Okay. So if I try here, I will see what I will get. See, I'm getting here 101 now. So you will get multiple different output for this one. If you run multiple times, you can see again 100, 101, 100, 101, right? So this is the issue with the race condition. So how we can fix this, right? So we have in Python something called logs. Okay. So how do we fix this? We need a way to say only one thread is allowed to touch this, the shared variable, right? So this is called log, especially a mutual exclusive log. So think of like a single occupy bathroom. So there is a one key. When thread A takes the key and enters, the thread B is supposed to wait outside. And thread A finishes, hang the key back up, and next thread B can take the key and enter, right? So for that we will understand with this example. So here we have same import like threading time, we have set counter. So this is how we can create log, threading dot log, mutual exclusive log. So counter log, so we have same function here, okay? But this is what is the difference here? In increment we have shared global shared counter, global shared counter. We are using for same way, but here you can see we have with counter underscore log, okay? So this will force the thread to wait outside if some thread is there. So at the same time, two threads cannot access this. Okay, only one thread at a time can use this one. So when I will created thread one like T1, T2 right here, and when I started T1, it go to here, and with counter it will what it will do? It will check like someone is there or not. If not, then T1 will go inside because no one is there currently. So it will go inside. It will use the like share counter. It will go time to sleep, and it will increment this one. Okay, set counter time plus one. And when it will start T2, it will go and it will check like counter log. So someone is already there. So T2 need to wait here. Okay, so T2 will go to wait. Wait here. So until the T1 is finished. So when T1 is finished, so that time third counter value will be third counter equals to 100. Okay. So when T1 finished, so T2 will check this. This is happened automatically. Okay. So when T1 is completed, so T1 will release the lock automatically, and when T2 can continuously will check like the lock is released or not. So it will check. So T2 lock is released. So T2 enter inside here. So here you will get the set counter value is 100. After that it will start again. So the value will go to the 200. Okay. So if I run this one, So we can see the final counter is the T2. So this is how we use the lock and how we can avoid the race condition. Okay. Next we have like why we always not see the race condition. That is also depend on the system. Okay, that I already explained to you. Thread pool executor. So before I will go to the thread pool. So here you can see we are using with lock, right? So this is also we have trade-off for this one when we use lock, because you can see we are using lock, so that time we need to wait until the thread one complete. So this is little bit you can say it will take times, okay, for execute the process. So this is good compared to the giving the wrong answer, right? So next we have thread pool executor. So what is the thread pool executor, right? So raw threads are powerful, but managing them manually, creating and starting joining each one get messy fast. So like creating you have 50 threads, right? If you create 50 threads and you need to start 50 threads and you need to join. And if you have 100, so like if you are want to fetch image or data from 50 URL, so you need to create this, right? So this will create problem and it will get messy, okay? And it will difficult to like debug also. So thread, so we have something called thread pool executor, okay? So I will copy this. So thread pool is like a team. Okay. So a team of workers have permanent job. So instead of hiring and firing new workers for every single task, that is expensive. So we hire a fixed team. Say like we create have three workers, and when task comes, we'll check which worker is available and we will assign that task to that worker. And all the worker is busy, then it will wait for some time and the worker is get free, and the worker is get free, so we will assign the new task to the that worker. So here you can see how we can create this one. So this is we have some URLs here. So you can see we are importing thread pool executor from concurrent.future. Okay, thread pool executor as a completed, and this is the request for request. We have URLs. So we have fetch URL function here. You can see with URL it will requesting and it will passing the URL is can and return condet read. Okay. Next we have our main function. So how this is working, you can see man with thread pool executor, max worker we are assigning 3 as a executor. Okay, so here you can see we are not creating any custom thread and we are not using thread dot start like t1 dot start t1 dot j. We just use thread pool executor and we give ask them to the set the max worker is 3. So when we have multiple tasks, it will use maximum 3 worker only. Like if we have 50 URL, okay. So it will what it will do? It will assign URL to the worker, each worker. So it will get one URL to the worker one, worker two, worker three. Okay. So you can see all three are very busy. So till now it will wait and like the worker one is completed task, then it will assign to the next task. So you can see three worker is executor. So executor dot submit fetch URL. So this is the URL and URL. So it will loop through that and it will call that. Next we have for future in as completed future underscore URL. Okay, so it will check it's completed or not. It will URL and it will fetch data future dot result from here. Okay, it will future, it will check is completed, then it will get here and it will print the data. So you see this is if you have set here like 50 worker also, max space to 50 worker, it will be same only, right? So you don't have to manually create like T1 start and T1 dot join for all the 50 tasks, 50 threads, right? So here you can see executor.submit, fetch URL and URL. So it's taking 2 URLs. What it is doing? So they send the fetch URL task to the thread pool and it does not block. It's immediately return a future object. Okay, it will return the future object, and so you can see future underscore URL. So it's having URL, it's reading URL from URL, it's passing this one. So how many object it will get? It will depend on this one. Okay. So here we have feature, right? So what is this? This is feature here. What we have this. So this is like you can understand like the delivery receipt when you order something. So online you get receipt immediately, but the package isn't there yet. So the future object is the receipt. It represents the eventually result of the task. Okay. So you can see we call this one. We are fetching data from URL, right? So this we are getting from the in this one, and here we are passing as a complete, and it is giving the future. So this is the kind of receipt because we will not get data immediately when you are calling the database or network call, right? It will take some time to get the data. And here you can see feature.result. So it will fetch the data from the result of the API call, or you can say data or response. Okay. So this is the thread execute thread pool executor for. So we understand how we can create threads, how we can like use concurrency for that. So how many worker we can create manually, and how we can use thread pool executor. Okay. So why thread pool executor instead of raw thread? Like why we need to use thread pool executor, right? So when we create threading dot thread, so we need to create each task for any new thread. Like for each task new thread we need to create, but we have fixed number of worker in the thread pool executor. Like concurrency control, manually we need to track using the start and join, but it will depend on the thread executor will depend on the max worker. Error handling, we need to handle error also there, but thread pool executor we have like future objects, so that will depend also. So how we can decide, how we can choose like which one we need to use, right? Thread or thread pool executor. So in my program waiting for external things like network, disk, database, API calls, so we need to use multi-threading, and if we are doing like heavy math process or any computational thing, that we need to use multi-processing. So for that we will be learning this in the next video. Please like, subscribe and share, and click on bell notification icon for the more updates. Thank you.